There's no denying that since that moment, the shadow all our lives. All men of goodwill earnestly hope that a realistic control of atomic weapons can and will be achieved. Meanwhile, good sense requires that all of us prepare for any eventuality. But wisdom demands, too, that we take time to understand this force. Because here, in fact, is the answer to a dream as old as man himself. A giant of limitless power at man's command. And where was it science found that giant? In the atom. A particle so infinitely small that it takes over 100 billion atoms. Scientists have learned a great deal about how they behave, and there are widely accepted theories as to what they're like. Let's start by meeting a leading authority on the subject, Dr. Adams. Now, observing the professor himself would seem that he resembling in many ways. Thank you. Now, the solar system together is electrical. The electrons, which are negative, are attracted by the protons, which are positive, and vice versa. But here in the nucleus are other particles with no electrical charge, called neutrons. Very which is science terms for families of atoms. To scientists, the atoms of the individual atom families, or elements, are identified by number. That is, the number of protons or positive charges in their nucleus. Each element, or family of atoms, there can be different members, each one having the same number of protons, but differing in the number of neutrons. The total of an atom's protons and neutrons is its atomic weight. Thus, in natural uranium, we have just one. Now, most atoms and most elements are content with their lot in life. We speak of them as being stable, but others are busy day and night, being what science calls radioactive. Like radium, throwing off powerful rays along with some of its neutrons and protons.
Its discovery gave men of science an idea. If an atom could change itself, why couldn't man change an atom? Using his bullets the very particles which radium threw off, a noted British scientist bombarded nitrogen and converted it to oxygen. Changing the elements. From that first experiment, others by the thousands followed as scientists devised ever more powerful particle accelerators, commonly called atom smashers, to transmute more and more kinds of atoms. All scientifically important, but hardly nuclear fission. Instead of a minor change, the atom split in two. Truly a discovery to change the world. For what had happened when the uranium atom split was a kind of double miracle of science. Half of the miracle concerned that binding force we spoke of before. Also have binding force, but for some reason it takes less of that glue to hold them together, and in the process of fission, a tiny fraction is left over. What happens to it? It explodes as energy, proving Einstein's theory that mass and energy are really the same. Similar to X-rays. But here are those neutrons bombard other uranium atoms, causing them to split of an amount of U-235 the size of a baseball. With this discovery, at the time the free world faced a war for survival, it was little wonder the first thought was a weapon. But how to obtain enough material for even a single bomb? Only a small fraction of natural where enough U-235 was separated to build the first atomic bomb. At Hanford, Washington, another impossible project proved possible when a huge plant was built for the mass production of the artificial element plutonium. This process involves what may be called the graphite slows down the free neutrons, and some of them give other U-235 atoms. neutrons hit U-238 atoms. And here's what happens. Remember, we said that U-238 wouldn't support it. Besides producing plutonium, the nuclear reactor makes possible two very important peacetime uses of atomic energy. Remember that the chain reaction process in the reactor creates tremendous heat, which scientists have learned how to control. Thus, adds tremendous weight. However, an atomic energy power plant has already proved feasible. The future supplying of electric power to entire cities is far from impossible, while nuclear power in locomotives, submarines, ships, and even very large airplanes. Working as tracers with such measuring devices as a Geiger counter became invisible detectives, aiding the cause of science in many different fields. Isotopes are being discovered constantly through the tireless work of modern pioneers in such fields as chemistry, metallurgy, medicine, and biology. Truly the superpower which man has released from within to his command.